The James Webb Space Telescope is a spectacular piece of engineering, more complex than any telescope we've ever sent into space. But Webb is not, in fact, in space. Yet. Astronomers and the interested public alike are getting pretty impatient to see this telescope in space and doing science. But some of the reasons it's not there yet are actually good. It's just part of building something that no one's ever built before. Webb was originally conceived as the successor to both Hubble and the infrared Spitzer Space Telescope. Once fully deployed, it'll be a multi-purpose observatory, capable of examining the planets in our own solar system, as well as exoplanets in orbit around other stars. But its primary mission is to delve deep into the origins of the universe itself, to as little as 200 million years after the Big Bang, when some of the earliest stars and galaxies were forming. By studying the light from these ancient and incredibly distant galaxies, scientists hope to uncover some of the secrets of the universe as a whole, how it came to be, and what its fate will be. But capturing the light from distant stars is no easy task. The universe is expanding, and as the earliest light travels toward us, its wavelengths get stretched out in a phenomenon known as redshift. As the wavelengths stretch, they become redder. The earliest stars are so far away, and their light is so stretched that it's no longer red, but infrared. That's why we build telescopes like Spitzer and now Webb, to see into that infrared. Its mirror is 6.5 meters across to make it as sensitive as possible. And since nearby sources of infrared light, like the Earth and the Sun, could drown out those dim old galaxies, engineers have gotten really creative in their attempt to protect it. Among these creative ideas is an immense sun shield the size of a tennis court. Not only would this help block the sun's glare, it would also keep Webb's delicate instruments cool. And nobody's ever built a sun shield like this before. Other infrared telescopes have used either smaller shields or liquid coolants. And it's ambitious ideas like this that have delayed the telescope again and again. It was proposed in 1996 for a 2007 launch. In 2019, as we're making this video, all of the parts of the telescope have been manufactured. But the launch has been pushed back once again, this time to 2021. Here's the thing, the technical challenges in building something like this are massive. There are nearly 350 single point failures on the telescope, which means that if just one of them breaks down, the entire observatory is rendered useless. And its planned orbit around the sun will take it 1.5 million kilometers away from Earth, so there's no way of fixing something that goes wrong once it's up there, like we've done with Hubble in the past. Everything has to be just right the first time. And obviously, that's even harder when engineers are inventing new technologies from scratch, like micro-shutters on the telescope's sensor, tiny doors that help block out unwanted light. And then there's that sun shield. Not only is it the size of a tennis court, but it has 5 separate kite-shaped layers, and they're each made from a special material coated in aluminum and silicon to help it reflect the sun's radiation and survive in the harsh environment of space. Oh, and then it has to fit onto a rocket. The whole thing must be folded up tightly during launch, then deployed once Webb reaches orbit, and that's hard. The tech behind the telescope's mirror is new too. With a total diameter of 6.5 meters, it's made up of 18 individually adjustable hexagonal mirrors, made from beryllium and coated with gold. Each mirror needs to be flawless and perfectly adjustable so the telescope can focus. Even the launch and deployment are new territory for NASA. The telescope will be transported by sea to French Guiana and launched on the French-made Ariane 5 rocket. NASA hasn't done any of these things before. Because every element of the design, construction, and launch is so complex and so new, it's been really difficult to estimate how long the project as a whole will take. And as each part of the process has progressed, it's become clear that these brand new technologies are taking longer than expected to get just right. And there's the usual dose of human error too, as you should expect with any huge undertaking. Perhaps the most infamous example is the bolt incident. During a vibration test, the fastening bolts that secured the sunshield cover weren't fully tightened because they were afraid they'd snag and tear the sunshield itself. Seems fair. But a bunch of bolts and fasteners came loose, dropping into the body of the spacecraft, and finding and retrieving them caused more delays. Because of all these delays, NASA appointed an independent review board in early 2019 to figure out why things were going so slowly and whether the project was even worth continuing. And the board concluded that what they called the awesome scientific potential that the telescope offers will be worth the effort and the wait. So the project is still on, and in fact, in August 2019, NASA announced that the telescope had at long last been assembled and was ready to move forward. With a long list of recommendations from the board and a lot of enthusiasm from all of us who have been waiting for this to happen for a long time, the launch is now set for March 2021. Let's hope no more bolts come loose before then. Thanks for watching this episode of SciShow Space, and hey, shout out to our sister channel SciShow Psych for recently passing 500,000 subscribers. SciShow Psych is all about the weird and wonderful things that brains do, like how we sometimes go all in on lost causes, sticking with them no matter how much we've invested. You can do it, James Webb Space Telescope. Check out SciShow Psych in the link in the description or at youtube.com/SciShowPsych.